So now let's talk about preparation. And we're just going to use some kind of standard laboratory items that you might have. In this particular case, we'll say 6 molar formic acid and solid sodium formate. And I want to point out that there's a few different ways to do this. So, option number 1. So the cheapest brute force method we had said to make a buffer was to take a weak acid or base and its conjugate and mix them together. So that's what I'm going to do here. We're going to say option number 1 given 6 molar HCO2H and solid sodium formate. And that has a molar mass of 68 grams per mole. All right, so how do we do it? Well, the first thing we do is we look at what we need. And so we need 0.5 moles of that formate, HCO2 minus, right, from NaHCO2 solid. We happen to know that moles is mass over molar mass, so moles is mass over molar mass. And we know we want that moles to be 0.5. So we can then find a mass as our moles times the molar mass. And in this case, that is 0.5 moles times 68 grams per mole. And we end up needing 34 grams of our sodium formate. Okay, so we took our molar amount of sodium formate that we needed based on our incremental additions, and now we just measure that out. All right. Now we need to get 2.75 moles of the formic acid from our 6 molar formic acid. So we need 2.75 moles HCO2H from 6.00 molar HCO2H aqueous. We know, and again, this is something I tell my students all the time, when in doubt, write the equation, use it as a checklist. Our equation for molarity is your moles over your volume in liters. We know the molarity is 6. We know we need 2.75 moles, so we need to solve for the volume. The volume in liters is going to be the moles over the molarity, and that's 2.75 moles. And we end up in this particular case needing 0.458 liters of 6 molar HCO2H. All right, that is the other half of our recipe. Now we just need to know how to combine them. And that is straight up solution preparation. And we've got fairly standardized instructions for that. We'll see how this marker color works out. Instructions on how to prepare this. Generally, you'll be using something like a volumetric flask. It would be good if we had a target volume that we're going to use. If you think back to the earlier constraints we had, we said we don't need to know a volume, so now we'll just make up a volume, and let's say to prepare maybe like 1.5 liters of our 3.00 pH buffer. So we're going to mix our 34 grams in 458 milliliters of 6.00 molar HCO2H, and then we'll do that in a 1.5 liter volumetric flask. And we'll just check our distance here. Then dilute to 1.5 liters total using water. All right, we just made 1.5 liters of our pH 3 buffer. Now take note, like that would have worked if I wanted to make 0.5 liters, just use a different size volumetric, because the mole ratio is all that matters. So once again, our option 1 here is to do brute force, where we just get some amount of our conjugate, get some amount of our acid, and mix them together and dilute to the line. So there is a set of instructions for that. Now let's look at the scenarios where you could add strong acid to the conjugate base in excess, or strong base to the conjugate acid in excess.